Hello everyone, I am Yashashwini, 5th SEM BCA from Maharani Science College for Women. My topic is regression. In this topic, we learn what is regression, introduction to regression, types of regression, applications of regression, advantages and disadvantages of regression. Let us see what is regression. Regression analysis is a form of predictive modeling technique which investigates the relationship between a dependent and independent variable. This technique is used for forecasting, time series modeling, and finding the causal effect relationship between the variables. Regression analysis is an important tool for modeling and analyzing data. For example, relationship between rash driving and number of road accidents by a driver is best studied through regression. Here you can see the curve. We fit a curved line to the data points in such a manner that the difference between the distance of data points from the curve or line is minimized. Next, let us see why do we use regression analysis. Regression analysis estimates the relationship between two or more variables. As mentioned above, regression analysis estimates the relationship between two or more variables. Let us understand with an easy example. Let's say you want to estimate growth in sales of a company based on current economic conditions. You have the recent company data which indicates that the growth in sales is around 2.5 times the growth is in the economy. Using this insight, we can predict future sales of the company based on current and past information. There are multiple benefits of using regression analysis. It indicates the significant relationship between dependent variable and independent variable. And it indicates the strength of impact of multiple variable on a dependent variable. Let us see the types of regression analysis. As there are 7 types of regression analysis. There are linear regression, logistic regression, polynomial regression, stepwise regression, Ritz regression, Lasso regression, elastic net regression. Let us see what is linear regression. It's one of the most widely known modeling technique. In this technique, the dependent variable is continuous and independent variable can be continuous or discrete. And nature of regression line is linear. Linear regression establishes a relationship between dependent variable and one more independent variable using the best fit straight line. It is represented by an equation y is equal to a plus b into x plus e, where a is intercept, b is slope of the line, and e is error term. Here we can see the graph. The line is linear. As you can see in the preceding figure, the data of point is linear. In other words, an independent variable count of likes. When changed causes the value of a dependent variable, that is number of shares, to change. Linear regression is very sensitive to outliers. It can terribly affect the regression line and eventually the forecasted value. Next, logistic regression. Logistic regression is used to find the probability of event is equal to success and event is equal to failure. We should use logistic regression when the dependent variable is binary, that is zeros and ones, true or false, yes or no in nature. Logistic regression is widely used for classification problems. Logistic regression does not require linear relationship between dependent and independent variable. It can handle various types of relationships because it applies a non-linear log transformation to the predicted odds. Since we are working with a binomial distribution, we need to choose a link function which is best suited for the distribution, and it is logit function. Next is polynomial regression. A regression equation is a polynomial regression equation. If the power of independent variable is more than 1, the equation y is equal to a plus b into x square represents a polynomial function. In this regression, technique, the best fit line is not a straight line. It is rather a curve that fits into the data points. Next, stepwise regression. This form of regression is used when we deal with multiple independent variables. In this technique, the selection of independent variables is done with the help of automatic process which involves no human intervention. This fit is achieved by observing statistical values like R square, T stats, and account metric to descent significant variables. Next is Ritz regression. Ritz regression is technique used when the data suffers from multicollinearity, that is, independent variables are highly correlated. In multicollinearity, even though the least square estimates are unbiased, their variances are large, which deviates the observed value far from the true value. By adding a degree of bias to the regression estimates, Ritz regression reduces the standard errors. Ritz regression solves the multicollinearity problem through shrinkage parameter. Next, lasso regression. Similar to Ritz regression, lasso. Lasso means least absolute shrinkage and selection operator. Also penalizes the absolute size of the regression coefficient. In addition, it is capable of reducing the variability and improving the accuracy of linear regression models. The three main important lasso regressions are: lasso regression shrinks coefficient to zero, which certainly helps in feature selection. Lasso is a regularization method and uses one regularization. If group of predictors are highly correlated, lasso picks only one of them and shrinks the other to zero. The last is elastic net regression. Elastic net is hybrid of lasso and Ritz regression techniques. It is trained with L1 and L2 pair as regularizer. Elastic net is useful when there are multiple features which are correlated. Lasso is likely to pick one of these at random. It encourages group effects in case of highly correlated variables. There are no limitations on the number of selected variables. It can suffer with double shrinkage. Let us see what are the advantages and disadvantages of regression. First, we see advantages of regression. Regression analysis refers to a method of mathematically sorting out which variable may have an impact. The importance of regression analysis for a small business is that it helps determine which factors matters most, which it can ignore, and how those factors interact with each other. The importance of regression analysis lies in the fact that it provides a powerful statistical method that allows a business to examine the relationship between two or more variables of interest. Disadvantages of regression. It is assumed that the cause and effect relationship between the variable remains unchanged. This assumption may not always hold good, and hence estimation of the values of a variable made on the basis of the regression equation may lead to erroneous and misleading results. It involves very lengthy and complicated procedure of calculations and analysis. It cannot be used in case of qualitative phenomenon, viz. Honesty, crime, etc. Let us see what are the applications of regression. There are three major uses of regression analysis, as they are determining the strength of predictors, forecasting an effect, trend forecasting. The regression might be used to identify the strength of the effect that the independent variable have on a dependent variable. Reference: Ashish Sen, Muni Srivastava, Regression Analysis. Thank you.